Good day everyone, I am Gabriel Alan M. Dumayuga, and in this video, we are going to discuss three main topics, which are speed versus velocity, Newton's laws of motion, and friction. Our group will be conducting an activity for each topic in order for you to better understand what these are all about. Understanding these three topics will help us to be knowledgeable enough in the field of physics, in which is important because it is the science that helps us understand various natural phenomena that are embedded in our reality. We use physics in our daily life activities such as walking, cutting, watching, cooking, and opening and closing things. That are the reasons why we are ought to understand this, because it is one of the factors behind all of the things around us. So without further ado, let's get started.
Just as distance and displacement have distinctly different meanings, so do speed and velocity. So first, let us know what is speed and velocity. Speed is a scalar quantity that refers to how fast an object is moving, while velocity, it is a vector quantity that refers to the rate at which an object changes in position. As you can see on the video, I am driving a motorcycle with speed that refers on how fast I am driving a motorcycle, and velocity at the rate at which an object changes in position to the location.
Law of motions. Newton's first law of motions, or the law inertia, states by every object will remain at rest or in uniform motions in straight line unless compelled to change its state by the actions of external force. This tendency to resist changes in states of motions. The coin stays in the place because the force applied to the plastic card was great enough to counteract the frictional force. The coin stays in the place because the force applied to the plastic card was great enough to counteract the frictional force. Once the plastic card was gone, gravity pulled the coin to the bottom of the glass.
Newton's second law describes how an object's velocity changes when it is subjected to an external force. The second law of motion states that force is equal to the change in momentum, which is defined as mass times velocity per change in time. Newton's second law of motion governs the behavior of objects when all available forces are not balanced. The second law states that the acceleration of an object is determined by two variables, the net force acting on the object and its mass. The acceleration of an object is proportional to the net force acting on it and inversely proportional to its mass. When the force is acting on an object increases, so does the object's acceleration. The acceleration of an object decreases as the mass of the object increases. Force is equal to mass times acceleration. The greater the mass, the greater the force for the same acceleration.
So, my name is Jensen Josh Villanes, and I'm here to explain and show an example of how is the third law of motion is done. So, first of all, the third law states that for every action or of force in nature, there is an equal and opposite reaction. If object A exerts a force on object B, Object B will be also exert on the equal force on object A. So today we have a little experiment with a balloon, straw, and a thread. So first of all, we're going to build the construction with um, by cutting a piece of straw and attaching it with attaching the straw in the piece of straw in the balloon. So we're going to start with a use of a duct tape. And then now we're going to insert a piece of thread in the straw, and then we're just going to make a sort of a zip line using the thread. So so this is what should the construction look like if you're going to do this in your home. Um, what I'm going to do is I am going to do is I will cut the balloon so the air will go out of the balloon, and then if I let go of the the part of the balloon will go forward like that. It is because of the third law, which as I explained earlier, um, if the object A, which is the balloon, exerts force, um, the object B will also exert the same force as the object A releases. That's all. Thank you.
Friction. Friction is the force that resists the sliding or rolling of one solid object over another. In addition, there are two types of friction. First is friction between two solid bodies. Under this, there are three types. First is static friction, wherein it is present at solid bodies at rest. Second, sliding friction. This is when one solid object slides over another. Third is rolling friction. It is happening when one solid object rolls over another. The second type of friction is the fluid friction, wherein it is present in liquids and gases. For you to better understand this, let's have an activity. So in this activity, we will be needing a 1/8 illustration board that will serve as a rump and two popsicle sticks. One that has something attached to it to make it rough, and the other one is just a popsicle sticks. So what I'm going to do is to place the two popsicle sticks on the cardboard And as I raise the rump or the cardboard, let's see which one will slide down first. So from the experiment, it is evident that the first stick that went slide down first is the stick with the smooth surface and was followed by the stick that has a rough surface. The activity that I just conducted is just saying that the rougher the surface, the greater the friction. That's all, and we hope that you learned something from this video. Goodbye and thank you.